So, when we're talking about the limits of continuous functions, many limits can be found by substituting the value that x is approaching just into the function. This will be true for all continuous functions, or functions that are continuous in the region where the limit is to be calculated. As long as we're trying to find the limit, it is continuous, we can just use direct substitution. So if a function y is equal to f of x is continuous at the point of a, then that means that the function has a value that exists when x is equal to a. The limit as x approaches a exists, so there actually is a limit, and that both these things, the value of x is equal to a and the limit as x approaches a, are both equivalent. All of these things need to exist for it to be continuous at this point. So, if f of x is equal to x squared plus 2x minus 3 is continuous at at 5, then the limit as x approaches 5 of x squared plus 2x minus 3 has to be the same as f of 5. So, if I state f of 5 is equal to 5 squared plus 2 times 5 minus 3, which equals 32, then that means 5 and 32 exists on the graph. This has to be true because it is continuous at this point. What if this doesn't work? What if we had a limit like x squared minus 1 over x minus 1 as x is approaching 1? Can we use direct substitution on this? No. Because when I substitute 1 in for x, I wind up with a denominator of 0 and a numerator of 0. The result is 0 over 0, which we refer to as indeterminate form. In order to solve the limit for this, we need to algebraically manipulate f of x until you have a function which you can substitute x is equal to 1. Which means that I'm going to take this limit, the limit as x approaches 1 of x squared minus 1 over x minus 1. I'm going to factor that numerator to get the limit as x approaches 1 of difference of squares, x plus 1, x minus 1, all divided by that denominator of x minus 1, and lo and behold, we can cancel out the x minus 1, remembering that when I factor that out of the numerator and denominator, there's still a point of discontinuity at x is equal to 1 because that was a non-permissible value. If this leaves me with the limit as x approaches 1 of x plus 1, now I can do the direct substitution. I can directly substitute that x is 1 for 1 plus 1, which is just going to give me 2. When I graph this out, what do I have? I have a straight line of x plus 1 with a point of discontinuity that occurs where my limit is at 1 and 2. As x gets closer and closer to 1 from the left or from the right, y gets closer and closer to 2. We're going to evaluate each of the following limits using that same principle of what we just did. The first thing we're going to do is we're going to factor what we can. So if I have the limit as x approaches 2 of x cubed minus 8 over x squared minus 3x plus 2, then I'm going to factor the numerator and the denominator. I'm going to factor the numerator using my sum of cubes to get the cube root of the first term is x, the cube root of the second term is 2, and then I'm going to take the first term squared plus the first term times the second term plus the second term squared. In the denominator, I'm just going to use inspection. 2 factors of 2 that add up to -3 are going to give me x minus 2 and x minus 1. And now we have a common factor that can be removed, that 2, or x minus 2. When I remove that, now I can substitute in 2 into my limit. So if the limit as x approaches 2 is x squared plus 2x plus 4 over x minus 1, then that means that this is going to be equivalent to 2 squared plus 2 times 2 plus 4 over 2 minus 1, which is going to give me a numerator of 12, a denominator of 1, and this is just going to equal 12.